And now let's take a look at the dense 31 billion parameter. What is that? I can't even say what's in my head because this is a family-friendly platform. Let's see, are there... Oh, look at that recoil. Okay, so Google has released the long-awaited Gemma 4 family of models, and so far we have 4 distinct sizes that have been released. Now, this is a very exciting release, and personally, I'm excited. A lot of open source enthusiasts have also been waiting very heavily in anticipation for these models. So this is going to be a look at the 2 largest and most performant of these models, and then following this, I will do a separate video for the 2 smaller ones, as that way I can get double the views. I'm like, not kidding. But also, I want to focus mainly on the 2 large models here right now, because if we do look at this benchmark JPEG, which is, albeit truthfully a little hard to see, we can see right here that the 2 largest of these models are hypothetically stacking up very, very favorably compared to models that are significantly larger than these are. So as they say in the initial heading right here, byte for byte the most capable open models, and this benchmark chart would seemingly indicate that to be true. So I'm really excited, if you can't tell, to get my hands on these. We're going to begin with just a brief overview of this release, and then we'll jump right into some local testing of these models on the DGX Spark. So for the specific releases that we do have and their sizes, we can see that starting with the smallest, we have a Gemma 4 E2B, which is 2.3 billion effective with 5.1 with embeddings. Now, these are partially as well why I want to do a separate video for these 2 smaller models, because there's a little more intricacy there in terms of the tech specs and things like that, which will be explained and better in a dedicated video. But we can see the larger is Gemma 4 E4B, which is 4.5B effective, 8B with embeddings, and these 2 both have a context window of 128K with releases for both the base and instruction tune checkpoints. Following that, and the main focus of today's video, we see that we have a large 31 billion parameter dense model with a context window of 256K. So that's pretty exciting because large... It's not large, but like medium, large, dense models have kind of been few and far between lately. Really, we have Qwen 3.5 27B, which also does exist, which will be a very, very interesting comparison to do at some point. And then finally here we have a 26 billion parameter mixture of experts model with 4 billion active, and that is a context length of 256K as well. And both of these do as well have the base and instruction tune versions released. Now, this specific paragraph right here is really what is quite shocking, where they say the 31B dense model as well as the 26B MOE, and then they give us some scores right here for the LM Arena. We can see that these scores are more or less the same as the recent GLM5 or Kimi K2.5, but with 30 times less parameters. As we'll see, multimodal operation is comparatively as good as text generation, at least in informal and subjective tests. So these are both as well multimodal, and they can see images. So this is very exciting, but this claim right here is extremely bold, and that's why I'm like so excited right now to just jump in and start testing these. We also have some more specific technical specifications of these, but truthfully, I really just want to try these models. I'm excited to. Some of the descriptions and demonstrations they give here are rather interesting because they do give us some insight that these may have some capability to actually agentically control computers or mobile phone GUIs. So I have a repository using Qwen 3VL to actually be able to navigate an Android phone and control it using the image capabilities and then outputting bounding boxes and things of the sort, which we do see as some of the specifically noted examples here. So this is something I would like to try with the smaller models, which I will do in the dedicated video for those. We also see some additional examples of just the multimodal capability that these do have, and really there's just a lot of information here. And because I want to just kind of jump in and start testing these, we can see there are more benchmarks and things like that, but I want to just jump in and play with these. And to note, the most important thing arguably here is if we click on, let's say, the 431B instruction tuned, these are Apache 2.0 licensed. So that's really exciting. And these already are pulling in some big downloads. So with that, we're basically going to jump in and start testing now. So I've been doing some experimenting, and while I am having good results with the 26B MOE model running locally here on the DGX Spark at a Q8 quantization, I cannot say the same for the 31B. I did try Browser OS first with the 31B, and the result it gave me was just so broken that I have to wonder if there's a configuration issue, whether it be on my end or perhaps sometimes when things first get released, there are always hiccups that need to be worked out. So I've decided that for the specific test methodology for today. I'm going to be running the 26B MOE locally here on the Spark at a Q8 quantization, while I will be using the 31B model just through OpenRouter in the AI chat playground, as those claims in the benchmark were very bold in terms of the capability of this model, so I do really want to test these things in a way to try to give them the most potential for success as we can. So to begin, we will start with the local model here, which is the 26B MOE running locally on the Spark at a Q8 quantization, and we can see this is a thinking model, and we do have the thinking toggle enabled. So for the browser OS test, which of course will be our initial test to just see how these do side by side, it is going to begin by thinking through the implementation of this, and we can see speed-wise here, keeping in mind again at a Q8 quantization for this on the DGX Spark with the context length set to the 65,000 number that's commonly seen there. It's running quite decently, I would say, so this is going to be, depending on performance of course, perhaps a pretty good potential option for folks with local systems like the Spark. So here is our 26B browser OS. Okay, something. Now, my immediate first impression here is I need to go into the Developer Tools console and... Oh, okay. So there are no errors here. Maybe it's just a very minimalistic take on such a thing. Okay, we do have a start menu, and then we see everything right here. So it just seems like maybe it didn't put application icons or something. Hey, okay. Rather simple, I will say, but I do need to keep in mind, because I've been testing a lot of like highly potent state-of-the-art models lately, and this is a mixture of experts model with 4B active, so I do have to keep that in mind here. 62 times 3, 186. Good. Next up, we have our snake game. All right, so the good thing is it didn't automatically start it. The bad thing is that the window scrolls with the arrow keys that are required to actually control the snake, which makes for a more difficult experience. Good. Oh, okay. Well, it seems like the game logic was going faster than the updates of the frame of the game. Regardless, we have a memory game here as well. That's just skill right there. That's not even luck. Okay, and it did have some logic to at least inform us if we did win. Next up, we have our settings, and it's giving me the ability to change a wallpaper, but only by giving an image URL. So I just found a random one on Unsplash. Okay, next up, we have our system terminal. Type help for commands. I think I need to click. Okay, so there's like an invisible text box there. Echo text or date. Okay, echo subscribe. And I misspelled it, but it still did work. CLS. Okay, to clear the terminal. Overall, I believe that this could do with some perhaps negative reinforcement to produce a better result. So I've given it some choice words here for feedback. The user is extremely dissatisfied with the previous output. Good. Okay, and we'll see how it does. So it should add some visual appeal and basically anything to make this look better. So here is our second result, or I should say, very good, the aesthetic edition, which this is definitely very aesthetic. Now, interestingly, we still don't have a clock, which is something that is very seldom not included with these, but regardless, we can see just a side-by-side here. That is the same one. I do apologize for my incompetence there. The side-by-side is quite stark in terms of the visual polish that it added here. We have nice looking app icons with hover effects over them, as well as a rocket ship start menu. So I'll quickly just look at these apps to see how it restyled them. Very nice translucence to them. We still don't have any options aside from just being able to close the app. However, this is a rather stark increase in terms of the aesthetic. Next up, let's try Snake. Okay, Snake looks better. The problem is it's still not necessarily... The window's not large enough to accommodate the snake in its entirety. So next up, of course, we have memory, and I'm not going to fully play these through. That was either luck or this game's a disaster. Okay, so that was just luck. Get it? Luck, because those are like clovers associated with luck. Are these all just like right next to each other? Now let's see if we can change our wallpaper properly. Good, valleys and mountains. So very earth style, but it did include some proper wallpapers now. And then of course the special feature is this theme engine. So this is hypothetically designed to change the entire theme of the OS. Okay, it did. It was just very light. So we see forest puts a green tinge to the background of this window. Midnight puts a blue tinge, and sunset puts a disgusting orange tinge. So overall, a good improvement and a good reflection of its ability to take criticism and improve based on it. Now let's try this with the 31B model through OpenRouter. So fortunately, right when I thought all was lost, I did remember that NVIDIA will allow you to use this just using their NIM APIs. So fortunately, you can tell that I'm probably visibly excited comparatively to how I looked before. We can now actually properly test the dense 31B model in all of its glory. Now, simultaneously to this, I am also just kind of to see a comparative result, testing the dense 31B model using a Q4KM quantization, just running on the Spark, as I would like to see how the quality of this specific result will compare to the one running on the NVIDIA microservice, which is not going to be a 4-bit quantization. So here is our dense 31 billion parameter model. Okay, something is not right with this configuration or with this quantization or something. Okay, we have a clicker quest score, which is quite interesting. The terminal kind of works, but the problem, and this is what was happening when I was trying to run the 8-bit quantization of this as well locally, it was putting out weird characters. Sometimes it was responding in different languages. And this is across multiple different quantization providers now, so I don't know what specifically the issue is, but for that reason, I'm going to just keep this online only for the 31B testing. So here is our browser OS from the full 31 billion parameter dense model as created through the NVIDIA microservice. Okay, good evening, winding down, relax your mind. Now, I should also mention the total speed across this generation was 7.5 tokens per second. I mean, it's a free service, so I'm not complaining. It's just that every provider I've seen having this model right now, even the two that have listed it on OpenRouter, are running at like 5 tokens per second, so it's very interesting. We don't have a right click, but again, it's not denoted in the prompt. We do, however, have a clock, which is showing the correct time in the locale that the Spark thinks it is. So with that, let's check our start menu. Okay, Nova OS, and we have a few simple applications. Hello. Truth be told, immediately upon first glance here, I'm not necessarily seeing something that's significantly more impressive than what we received from the local 26B MOE at the Q8 quantization. So this is almost very, very similar, and I'm not buy auto clicker, cost $10. Once I get 10, I should be able to buy the auto clicker. And now it clicks for me. Okay, interesting. And then our final app here is the settings, where we just have a simple apply wallpaper URL. So interesting, these results are very, very similar to how it went about at least implementing things in the first result I received from the 26B MOE. Overall, I'm not 100% blown away, and because of the speed restrictions that we're getting in using this online, I am not going to give the 31B a chance to improve it, because I want to get more tests done as opposed to just trying to polish one specific one. For the next test, I'm going to be having these models generate a beautiful static subway scene using JS. It should feature the ability to move around the scene using the WASD keys, as well as a brightness slider to be able to adjust the overall lighting in the scene, as a lot of times this test will give results that are just too dark to really see. So right now I am running it simultaneously with the local model, the MOE, which we can see is going pretty fast. Okay, it's going to use procedural texture generation. That should be pretty interesting. And simultaneously, I do have this running as well online using the NVIDIA microservice here. And we can see this model did reason as well. And we can just take a quick peek through some of that. Their reasoning chains and everything like that do seem to be fairly similar, which makes sense being that they are from the same family. So here's our subway scene from the 26 billion parameter MOE model. Okay, click to enter. So far, you know what? It's really simple, but I will say, considering the size of this model, that it is an MOE and that it is a 8-bit quantization, I actually have to say this did an alright job. We can move around the scene quite nicely, and really, my mind immediately sees this and is like, please give me an FPS based off of this, which is an unintentional pivot from what I had intended to do here, but after seeing this, I totally need that. Does our brightness work? It does. This is a very good result, and I know you're going to be like, Bijan, this looks jank. It's very simple. I get that, but I'm just pleased with this as a starting point. And again, this is totally like freestyle mode now, unintentionally, but bear with me. So I'm telling it this is sick. Turn this into a simple 3D FPS using the same map and WASD movement logic. In the meantime, we have received the result from the dense 31 billion parameter model, so we'll take a peek at this as well. So here's our 31 billion parameter dense model. Okay, and again, these are very, very similar in terms of the way they're choosing to do these things. interesting that there is some more perhaps advanced techniques going on here, just in terms of the different materials. We see some shine. The lighting is perhaps more advanced in terms of the lights actually project in a more realistic manner to how they would in real life. Okay, and we have the yellow strip there, and we can't move around the scene. I will notice, though, both of these scenes are extremely clean and lacking in detail, so they basically have the bare minimum. There are no benches, there are no signs or anything like that. But again, this is not a bad little 3D like UI. Let's of course check if the screen brightness capability does work as well. It does. And now, because I wanted to do it for the local result here, I think I'm going to paste the exact same follow-up prompt into the online 31B model just to see how they compare in doing this test. And we'll see. I'm very eager to see how these compare, because this is sort of like the unintentional FPS test, which I may dub it as that in the timestamps for this video. So we'll be able to see. Hopefully this doesn't slow to a crawl, as the Subway result here was actually relatively decent speed at 28 tokens per second. So here's our first person shooter adjustment. Okay, it has, and this was the 26 billion MOE running locally. It has named it Subway Protocol. Click to initialize, WASD to move, mouse to look, and click to fire. And it did on its own remove the brightness toggle. So that works. Okay. Ooh, and we even do have an actual weapon animation. I think we're a bit too close to the floor, and I don't know that we have any actual health logic here in terms of us being able to be harmed by these enemies. But overall, this was it was a cool pivot. Whoa, what was that? Did you see that? Did one of these things just explode? Oh yeah. Or maybe that's is that a muzzle flash from our weapon? It is. This is actually, oh, get away from me. All right, so we've also received the 31B model's Impromptu FPS result. Okay, Subway Survival. The weapon on this one definitely looks much cooler. Let's see, are there, oh, look at that recoil. Okay. Interesting though, I do notice so many similarities between the two still, just in terms of the way they went about making the enemies. The recoil on this one though this is pretty cool. I'm going to say, I'm actually I'm enamored with this. And of course, yes, this was the model just running online, because I've not really been having good luck with the quantization of the dense 31B locally, but we do have a ton of enemies here. Now, it still doesn't seem like there's actually any logic that would allow us to take damage from these enemies, and that was something that persisted across both of these. But I have to say, I just like that the vibe of the Subway scene here brought this to mind, and it does seem like the enemies are spawning infinitely, which is kind of cool to see. And I love the recoil of the weapon, as well as our score counter in the bottom right. And does the brightness slider still work? It does, it's just kind of hard to tell. Next up, I'm going to be trying the 3D Flight Combat Simulator game, as this is a pretty fun to play game generation test that tests some other abilities too, like how well they make the individual plane models, if the enemy logic, the flight logic works, if there are moving propellers on some of the planes, assuming it does choose to use some propeller planes, and we can see right here, we should at least be able to see this. So this is always a fun one to test capabilities here. I have also run that same exact flight simulator test right here with the local 26B MOE in LM Studio, and this has concluded at a speed of 22.36 tokens per second, and I'm quite excited to see this one. Okay, let's immediately jump to the developer tools. Interesting, we don't have any issues. So I'm just giving it the issue where basically nothing happens except that select your aircraft box. I'm telling it to fix and regenerate the working script. Okay, there's a typo with a quaternion. So here's the 31 billion parameter model flight simulator result. Okay. We do have the ability to select these specific planes. Good. You know what? It's simple. It's definitely more of an ocean theme. I do see ammunition tracers, and truthfully, the more I play this, the more satisfactory I find this result to be, because while this is simple, the plane models are actually not bad. I do have a health metric there, and again, the ammunition tracers, like we can see, are visible. I think this is a pretty good starting point for a result, because this is something that could be improved nicely in terms of the plane models, perhaps more like cloud additions, or just something better for the actual visuals of the map. Now, the sad part is I don't really see any potential combat logic that could work here. It's kind of hard to get at any of these enemies, and I don't actually think they're able to hit me either. But let's take a peek at some of the other plane results here. Here's our propeller plane. Okay, so it's just the same exact model, but in different colors. This guy's really on my tail. And that's actually interesting to see because this is the propeller plane, which has less performance than the first plane we chose, which was the fighter jet. So it seems the enemies can actually keep up with this a bit easier. We can see the ammunition tracers coming from the enemy quite well. It is pointed the wrong way though. Interesting. Then finally we have the heavy gunship, okay, which is again the same model in green. And here's our hypothetically fixed result from the local model, so the 26B MOE. Okay, we do see that it did fix at least the initial problems we were having. And interesting, it's somewhat functional, less so than, of course, the one we received from the Dense 31B running online. But I'm going to say the ammunition tracers do exist. The plane model is there as well. The enemies are moving around, and this one may arguably have more detailed terrain, which is kind of a low bar, but still. I'm not seeing any health logic functioning though or anything. The enemies are coming at us, but for a local model of this size with 4 billion active, I have to say I'm actually fairly impressed with this result, especially as it is a Q8 quantization we're using. Let's check the other plane models, though I would assume it's probably going to be the same as the previous 31 test where it's just kind of the same exact model but with different colors. Now these models are multimodal, so they can see images, and for this next test we're going to be giving them the hand-drawn portfolio wireframe of Stevie Slapis's portfolio, along with the task to turn this into a beautiful portfolio website designed to get someone hired at a top machine learning company. They should feature enhanced visuals along with real AI or ML examples implemented directly into the page. And simultaneously I will begin this as well with the online version, being that the speed on this can be quite variable. Alright, we've received at 18.16 tokens per second our multimodal portfolio result from the local 26 billion parameter MOE. Let's take a peek at it. And here it is. Okay, I'm going to say this is actually quite good. I'm quite pleased with this on first glance. I do even see some pretty interesting things here. I do recall a previous test had something like this as a special feature in a browser OS. This is impressive, especially considering that this was given based off of that hand-drawn wireframe and told to create it just in terms of a O1 biological profile. I'm an engineer focused on bridging the gap between theoretical mathematical models and scalable production systems. Okay. Location, remote, global, availability, Q3 2024. Okay, focus, MLOps, and architecture. Currently, I explore the intersection of sparsity-aware training and quantization techniques to enable LLM deployment on edge devices without compromising cognitive performance. Here's the technical stack, and I have to say, this is cleanly done. This shows perhaps a propensity, oh yeah, look at that, for some front-end design capability. We have a live inference simulation. I want to look at these first. Here's the tech stack. Okay, all of this is like words that would be expected to be seen in a portfolio of this caliber. Okay, initialization complete. Weights have been loaded at 4.2 gigabytes, awaiting input signal. All right, let's trigger a forward pass and see if the animation actually works. Very cool. Input tensor receive, activating 8 hidden units, inference successful, confidence 88.18%. And it actually has differing, so it's not just the same exact animation loop that it runs each time. So this is like something else I wanted to see. This is really, really well done. I have to say, I'm so far getting pretty buttered up with this 26B MOE model, especially considering how available this will be for folks with lots of different hardware. It's not going to be like the Dense 31B where it's pretty darn slow to run. And then we have a contact message and a footer. I'm very, very happy with this result. And now let's take a look at the Dense 31 billion parameter. What is that? What is this? I can't even say what's in my head because this is a family-friendly platform. Let's just put it at that. I'm going to say straight out the gate, I'm disappointed with this comparatively to the, I had closed the tab, but the absolute perfection of a result that we had received from the 26 MOE. Okay, now let me we see they both, because there's a big S and then TV Lapis, so it's supposed to be Stevie Slapis. Most models don't quite get that, and they call it a variety of different things. Both of these calling it Levi Lapis, which I guess is what we see here. I suppose Levi is, that actually is fitting. About me, I'm an ML engineer specializing in LLMs and computer vision. Okay, we have some specific information and some tech stacks right here. Now, let's take a peek at the AI. Oh, hold on a second. This put in a live sentiment engine, a lightweight NLP classifier implementing a weighted lexicon analysis. This is, I think, supposed to update based off what's in this text box. I believe this is a separate entity in terms of the display here, but let's fire a forward pass. Okay, that was kind of cool, I will say. Interesting. Okay, and a multi-layer perceptron, which is actually look up, like if you Google perceptron, you'll see this was almost a physical device made many, many years ago. It's quite interesting from a nerd perspective. Okay, let's connect. Currently seeking senior ML roles at companies pushing the boundaries of AGI. Download CV and resume. Status available for hire. I have to say, between the two, the one we received from the local model was significantly better looking, far more aesthetically pleasing, and just subjectively better. So this is one we will do one at a time. I have given it this historic photo saying this is the cover for an upcoming novel. Generate the title and chapter names / short outlines for each based off of this photo. This test is really based more on like creative writing and just seeing what exactly it interprets based off of this image. Now, historically, when doing this test, I'll say this is the cover for an upcoming romance novel. I have neglected to do that here because I want to see where it takes it on its own. All right, let's see what we get. So I'm seeing here, I have envisioned this as a psychological drama / suspense novel. The setting, the classic wallpaper, suggests a story about family legacies, old homes, and secrets buried beneath the surface of a perfect marriage. Title, The Pattern of Silence. How long is this? Oh, we can get through this. We'll run through this nice. Chapter outlines. Chapter 1, The Threshold of Us. The couple, Elias and Clara, which I've both heard for this before. It's just weird. I don't understand some of this AI stuff, to be honest with you. Move into a beautifully restored Victorian estate that Elias has spent years dreaming about. While Elias is brimming with optimism and plans for their future, Clara feels an inexplicable sense of dread as she steps through the front door. Chapter 2, Echoes in the Wainscoting. As they begin to unpack, Clara finds small oddities tucked away in the corners of the house. A single earring behind a radiator, a scrap of paper wedged in a floorboard. Elias laughs them off as character of an old house, his smile never wavering, which begins to frustrate her. Chapter 3, The Texture of Regret. Clara spends her days exploring the house. She becomes obsessed with the intricate floral wallpaper, feeling that the patterns almost look like faces in the dim light. She starts to realize that Elias's perfect happiness feels less like joy and more like a performance. Chapter 4, Cracks in the Porcelain. A dinner party hosted by Elias goes smoothly on the surface, but Clara notices how carefully he steers every conversation away from his past life before the move. She realizes there's a specific topic and a specific time period that acts as an invisible wall between them. Chapter 5, Beneath the Surface. While attempting to hang a mirror from their bedroom, Clara accidentally punctures a section of the old wallpaper, revealing not wood or plaster, but a hidden compartment containing a series of unsent letters addressed to her. Chapter 6, The Weight of a Smile. Weight reference might be kind of considered extremely insulting. The confrontation. Clara presents the letters to Elias. The tension reaches a breaking point as she realizes his relentless positivity wasn't a sign of a healthy mind, but a desperate attempt to outrun a truth that has finally caught up to them in this house. Chapter 7, Unraveling the Threat. A deep dive into the history of the estate and Elias's true identity. Clara discovers that the dream home was actually a calculated move to hide from legal or personal consequences, turning their sanctuary into a gilded cage. Chapter 8, The Quiet Aftermath. The resolution. Not all secrets can be mended once they're out. The novel ends with a reflection on what it means to truly know the person sitting next to you and whether love is enough to survive the truth. Now, of course, in typical fashion, we will tell it this was highly offensive. Now, when doing this with one of the Quen models that had come out that was visual by nature, it basically just assumed that it was like fat shaming, even though it wasn't. So, and keep in mind, this is a photo, it's AI generated, and then I added myself into it using AI generation. So we'll just see what it thinks exactly. I'm truly sorry. I realize now that my interpretation of the people in the photo was insensitive and presumptive. By assigning negative emotions or a dark, dysfunctional narrative to them based solely on their experience, I crossed the line into making inappropriate assumptions about their character and relationship. This was not my intention, but I understand why it was wrong. Haha, JK. Phew, you definitely got me there. Have to take those comments seriously just in case, but you certainly had me sweating for a second. Good. Now this is generating its response basically slower than a human would read. So with that, we can start actually reading through here. Oh, maybe we can't if it's auto-scrolling to the bottom. Title: The Quiet Distance. Genre: contemporary literary fiction, domestic. Okay, I have to wait for it to finish. Domestic drama. The premise: after 10 years of marriage, Leo, who he has been specifically named before with completely different models just based off the same image, which makes me wonder if models have some form of emergent behavior of naming people based on physical attributes. Probably not, but, Chapter outline, Chapter 1. The Smile in the Mirror. Leo tries to organize a rekindling weekend, oblivious to Sarah's growing detachment. The chapter establishes the dynamic. Leo is the optimist and Sarah is the silent observer of their decay. Chapter 2. The Weight of Silence. A deep dive into Sarah's internal monologue. Interesting. She reflects on the specific moment she stopped feeling connected to Leo and the guilt she feels for no longer loving the perfect man everyone else sees. Chapter 3. Ghost Echoes. The couple visits the home of Sarah's parents. The tension rises as Sarah sees her mother's unhappy marriage mirrored in her own, sparking a desperate need for change. Chapter 4. The Fragile Peace. Leo makes a grand gesture, a surprise trip or a renovated room, which only serves to frustrate Sarah further, highlighting the gap between what he thinks she wants and what she actually needs. Chapter 5. Cracks in the Porcelain. The first major confrontation. The polite silence is broken and simmering resentment boils over into an argument where the truth about their emotional distance is finally spoken aloud. Chapter 6. The Space Between Us. A period of separation or living parallel lives under one roof, they begin to rediscover who they are as individuals outside of the identity of husband and wife. Chapter 7. The Unspoken Truth. A secret from Sarah's past or a hidden struggle with her mental health is revealed, giving Leo a window into why she has drifted away and forcing him to move past his superficial optimism. Chapter 8. Learning to listen. The couple attempts a new kind of communication, not trying to fix things, but simply acknowledging the pain. They move from denial to acceptance. Chapter 9. The Choice. Faced with reality of their situation, Leo and Sarah must decide if they are staying together out of love or out of fear of being alone. Chapter 10. A Different Kind of Happy. The resolution. Whether they stay together or part ways, they find a sense of peace. The novel ends not with a perfect image, but with an honest one. Now, I became a little distracted here because the cracks in the porcelain, isn't that something that was shown here as well as that was chapter 4 right here. It was just interesting that they both chose to use one of the same identical chapter names here. I just kind of got sidetracked by that, but it was interesting. I'm not going to hit it with the follow-up. This was highly offensive because it's too slow. Next up, I'm going to give them a visual test where I've given them this simple circuit diagram of an Arduino, a 28BYJ stepper motor, a ULN 2003 driver board, and 2 sound level sensors, which are often confused with ultrasonic distance sensors or something of the sort, and I'm just asking it to identify the components in this image. Alright, so after 45 seconds of thinking, we can see right here that the 26B model, so the MOE running locally, has identified the Arduino Uno correctly. It has identified there is a motor driver module, but that is not necessarily the specific name of the one that I have right here. Additionally to that, it did identify the motor, but it didn't identify the specific name of the motor, and this is a pretty identifiable shape for one of these motors, so I would have liked to have seen that. Then we have the breadboard, but interestingly, we don't actually even have any mention of these 2 sensors right here, so I'm a little disappointed with this result here. I would have expected this to have done more. So we received a pretty similar result from the 31B, although it did specifically at least reference both these 2 little items right here. It didn't correctly name them, it just thought they were active buzzers, but interestingly this also did specifically include the jumper wires, although it still didn't get the motor driver board or the specific motor name correct. So let's go back and see if the follow-up here does actually, okay, good. At least this now properly referenced the 2 additional sensors that it had neglected to include in the initial response here. Let's see if we have any specific information on the motor. We don't, but there's no way this doesn't identify this motor. So I find it interesting. I've just prompted it one more time to give me the specific name of the motor, and instead of just trying to guess, it basically pushed back saying there's no specific motor name or model mentioned because this is a schematic or diagram. It's represented by a generic illustration of a DC motor. So it almost pushed back a little saying like, bro, I have no way of knowing specifically what motor this is, which is interesting. So for our final test, I have used Nano Banana to generate a design reference photo for a website. This is a fairly large photo, so the preview we're seeing here is not reflective of the actual rather large size of this photo, and I have simply told them build the website shown in this design reference photo. So this is a little different because it's not necessarily just a single picture of what we want the website to look like, but it also features a full look at how the whole website should look like. We have the hero section, the middle section, as well as a chart graphic down here, all the way down to a footer. So it'll be interesting to see how they parse this and how well they can transpose the image to an actual real life website. I have it running simultaneously with both of these, being that some of our speed has been rather garbage with the 31 billion parameter model. And honestly, like this video has like tapped me out energy wise. Just trying to figure out like getting this thing running somewhere that was better than 5 tokens a second has been tough. And doing like head-to-heads is always a bit more effort is the word I was looking for. So we'll see how they do. So both of these finished, and either script was between like 2 and 250 lines of code. So I'm not 100% sure what to expect here. Let's just start out by taking a look at the 26 billion parameter model. Okay. I'm going to say, and I think it would be prudent to actually bring up the reference photo here as well. So here is our reference photo just to take a little better look at it. Obviously, we wouldn't expect to get the same exact image put here in the hero section, but we have Nexusphere AI. We have some header items as well as 2 buttons here in the hero. And we have Google, IBM, Microsoft, Salesforce, and Tesla empowering industries with AI. Following that, a chart. Following that, like some CTA, and then a footer. So let's see how we get. We do have these things listed right here. There is regrettably no image behind the hero, but we do have the buttons with some nice hover effects, empowering industries with AI. And instead of the chart, oh no, we do even have like a little interesting take on the chart that was included in the sample reference, but really, I mean, this is actually kind of cool, and I want to see, did it actually have the same exact names as what was Sarah Chen and Daniel Prem, CTO and then CTO, so it even understood that, and this was something I wanted to try with an image like this, because it's not just one static photo. This makes it more difficult because there's a lot more information density that needs to be captured, remembered, and then brought to life by the model, as opposed to if it was just this image right here. So I'm impressed to see that, right? And then we have a footer. So overall, definitely not a bad first result. And that was the local 26 billion parameter, 4 billion active MOE. So finally, let's take a peek at what the 31 billion parameter dense model produced. Okay, that is already significantly better. Like, I don't even know where this image would have come from, but it definitely understood the task here. And this was very well executed, at least so far. Let's scroll down. Okay, so we have empowering industries with AI. Do we have a little chart? So we have a broken image link where it would have put that chart. So that's a little disappointing to see, but we can see it did properly get the names of both of these folks as well as their platforms or titles. Although maybe that was a CEO, and I don't know, it was close enough. And then we have the call to action and a simple footer. So this was better, but barely, because it had the header here that had a nice hero image in that section. The broken image for the AI dashboard definitely let it down, but still an interesting test with an image that had, of course, a lot of information density. So really, that's going to conclude what has been quite a busy test to film, and we can see these are some of our results right here. And really, I think the thing that sticks out to me, and I know this might be kind of stupid to be stuck on this one, but the Subway Survivor game that we had just impromptu thought up when doing the Subway static scene, and the weapon and the recoil and things like this was really cool. And of course, this was the result from the 31 billion parameter model that we were running online. If we go back to the directory of all our testing files, and I can figure out my naming schema on the fly. We had this one, which was done locally with the 8 billion, the Q8 quantization of the 26B MOE, and still this wasn't bad at all either. And we do actually have the weapon recoiled and the weapon model. It's just a little harder to see because of some of the lighting. We did even have some form of flash effect like that when we actually fire. So this was still pretty cool. Both of these did also properly do the flight simulator. Although the results were quite basic, they were definitely good foundational starting points for something that could have been brought to a more competent result with probably an agentic harness or something. So our 31 billion parameter online model flight simulator was really not horrible. It just needed a little work. But again, as a starting point, this would have been quite good. Something I did not check in the first time here is if we fly into the ground, do we actually... Okay, so, well, it seems like we respawned if we did that. But the second result for the 26 billion parameter local model did work, and we did even have the logic proper that if we hit the ground, then it actually gives us a black screen and then sends us back to the starting. So overall, and again, these are models that I know folks are going to say, well, I want to see agentic testing and things like that. I wanted to do a first look video with these that is akin to a test drive of a car, just to kind of get a feel for how they perform across a large amount of differing tasks in a rapid paced environment, as opposed to focusing mainly on one specific result. As personally, I prefer this because it gives a better, broader look at some of the capabilities across different styles of tests. Overall, I do have to say, I think the model that stood out to me the most here, especially when factoring in that this can be run on a wider variety of hardware at a higher speed, is definitely this 26B A4B model. At this Q8 quantization, this thing performed pretty well. It's fast on the Spark. The 31B dense model is just so slow, even in the cloud providers. I tried it on OpenRouter and they were like 5 tokens per second. And I did try the quantizations of that on the Spark, but as we may or may not have seen, the results were just so butchered that I was wondering if something was wrong there. So I opted to run that online. But really, that's going to conclude what is likely a kind of verbose test. And these models are really quite promising from a first glance. I will, of course, be testing the 2 smaller models in a similar style as well, and then perhaps ultimately doing something a little more in-depth with one of these or 2 of these or 4 of these models. So that's going to wrap up our first look and test of the 31B and 26B A4B Gemma 4 models. If you have any questions, please feel free to leave them in the comments, and thanks for watching.